All right, so we're going to start with class now. Just heads up, today's class should not be as long as yesterday's. Yesterday we went for almost the full 45 minutes. And sorry about that, but I just wanted to make sure that you guys could continue to do the practice after I went over everything. Again, today we probably won't take as long to go over the stuff today. You'll have more time for independent work time or just for me to go over questions. And thank you, Kevin, for reminding me to record this session. If anybody realizes that I'm not recording this, please let me know so that I can go ahead and do that, okay? So when we're looking at today, we're looking again at lesson 1, exponential expressions. We started that yesterday. We're going to continue with that for today. So just remember that objective that we were working towards was that we're going to be able to write and also evaluate numerical expressions, right? So this piece here about evaluating numerical expressions, again, is basically like just finding the answer to the math problem. So in this case here, today, we're mostly thinking about using the order of operations, or we usually say PEMDAS, to help us evaluate these expressions, right? So thinking to that, I actually just remembered about this scenario that came up last year, right? There's a couple of different versions of it, but it says here, can you solve this math equation that's stumping the internet, right? And I want you guys to try it yourself to see what we get. And you might be surprised that people are gonna get different results, right? So this article looks like it was published August 2nd, 2019, so a little less than a year ago. And it says, math wizards, are you ready to solve a problem that's baffling the internet? A seemingly simple math equation on Twitter has even the most skillful mathematicians scratching their heads. So let's take a look at this question here and see what people think of it. So it says 8 divided by 2 multiplied by 2 plus 2. What's that equal to? So I'm gonna give you guys about 30 seconds, think about it, try to work it out. And then I want you guys to use the chat to write down what you think the answer to this question is, all right? Okay, so I'm seeing some people say 16, I see 8. All right, so don't write out how you're getting it yet, but just write out the answer that you're getting. Okay, I see 1. And Casino Jack, can you just change your name for me so I can properly get attendance? Okay, so it seems like a lot of people are getting 16. I saw somebody get 1, I saw somebody else get 8. Now, when we're doing a question like this, right, the main idea here is to work out and do the order of operations. So let me just see what it says down here in the article, right? Right, PEMDAS. So what it actually says here is that a lot of people were doing this question, and I think they said that some people got answers like 16 and 1 were the most common answers, all right? But actually, yeah, let's just try to work this out together, all right? Now, the problem here is if you're using PEMDAS incorrectly, because you do have to be careful when you're working with PEMDAS, and you're right at the top here, all right? So remember, parentheses, exponents, multiplication, division, addition, subtraction, right? So I'm gonna show you the incorrect approach first. So the incorrect way to do it, which some people end up doing by mistake, is it says 8 divided by 2 times 2 plus 2, right? So first step everybody knows, okay, so parentheses. Let's do the parentheses first. So I'm gonna rewrite this, 8 divided by 2 times 2 plus 2 is just 4, right? So I did parentheses. And I'd say, okay, are there any exponents? No. So next I'm going to do multiplication. So 8 divided by 2, this is going to be multiplied since they're next to each other. The multiplication is assumed. 2 times 4 gives you 8. So they say, okay, now division 8 divided by 8 is equal to 1, right? So that would be using PEMDAS if you're going in order, doing multiplication first and then division, right? But this approach here is actually incorrect, right? I'm gonna explain the reason why. So what you actually wanna do here is it's 8 divided by 2 times 2 plus 2, right? First step was fine. First step we did was parentheses. So we did bring this back down, 8 divided by 2 multiplied by 2 plus 2 is just 4, okay? That step is right. Now there's no exponents, so the key here is it's actually multiplication or division. So these two are at the same level, you do whichever one comes first when you're reading from left to right. And then afterwards, the same thing with addition or subtraction, these two are grouped together. So whichever one comes first from left to right, right? You don't always have to do your multiplication before division. So if I'm reading the statement here, 8 divided by 2 times 4, I actually need to do this operation first, right? So what I should do first is 8 divided by 2, which gives me 4. And then I have 4 times 4, right? You guys might see me use a dot for multiplication. So moving forward, especially in 7th grade, 8th grade, and beyond, we tend to stop using an X for multiplication once you start using more variables, right? So usually we start using more dots for multiplication. So I'm gonna see 4 times 4 is equal to 16. And I'm actually really glad that I saw a lot of you guys got 16 as the answer, right? If you didn't get 16 as the answer, don't worry about it, that's fine, right? The answer is supposed to be 16 though, and not 1. If you did get 1, hopefully we can see here why the answer should be 16, but don't feel bad that you got 1, because a lot of people got this wrong, right? Even some math teachers got it wrong because people are so used to saying PEMDAS and forgetting that it's either multiplication or division, right? The order matters. So just hopefully this example sticks in your head and just helps you to memorize that, right? Multiplication, division are at the same level. So typically, actually, when I write PEMDAS out, I think it's actually better to write it like this. Give me 1 second. So I would write P, E, and then maybe MD, AS. Or just some other way of making sure that you're differentiating that this multiplication and division, this addition and subtraction are at that same level, right? You do whichever one comes first. So now let's just get back into looking at the rest of this lesson here so that you guys can go on to your independent work, right? So we did some examples with exponents. We reviewed the order of operations. Remember, this is PEMDAS. This graphic here shows us parentheses at one level, exponents, multiplication, division together, addition, subtraction together. Right? And remember that acronym, please excuse my dear Aunt Sally, can help you to memorize PEMDAS. We saw some examples. I believe we stopped around here, right? So this is an example. I'm not going to do it for you guys, but just remember, follow the order of operations. You do your parentheses first, followed by your exponents. Then over here, multiplication first, do that division, do the addition, right? Just take your time with it, do it step by step. It does help to write things out, but actually this question here isn't even asking you to solve the problem, right? This one is actually only asking you, what would you perform first, right? So a lot of times in math, this does happen often. Just make sure you read the question before you start, right? Because I just did the same thing. I said, okay, so I'm looking at this here. I said, okay, bam, 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 do this, this, this. I just wasted a bunch of time when all it asked me to do was figure out the first expression, right? So you just told us in the chat, 9 minus 3, right? So it's easy to waste time if you say, hey, I know this stuff is easy, I'm not even gonna read it. And I just wasted a bunch of time for no reason, when all I had to do was say, okay, so parentheses is first, that's what I'm gonna do, right? So this over here is another example of just a situation that involves the order of operations. So I have this long expression here, 10 divided by 2 plus 5 times 3 squared minus 3 plus 6, right? And this here is just really breaking down how we go about solving that question, right? So I don't feel like I need to go over this. If anybody wants me to go over this expression, how we go about solving that, just please let me know and I can do it, but it's all kind of given for you here, every step along the way, right? First it says start with the parentheses, then you go on to doing this exponent, then you do your multiplication, you do your division, right? And this one here, again, remember the key thing is division first, from left to right because that's what you saw first, this division operator first on the left-hand side as opposed to the multiplication there. So please, I still see students in 7th grade, 8th grade that make that mistake. Just try not to make that mistake. All right. If anybody had questions on this section here, please let me know, right? This is just kind of going over writing a couple of expressions and then solving those expressions. So make sure that you finish through this activity here. And if you have questions, please stop me and let me know, but I'm just going to continue going through the remainder of the slides here. All right. So this slide here, it says in the lesson activity, you learned how to write numerical expressions, right? So remember the example we saw with the window panes, and we said, okay, it's 4 panes across, 4 panes down. So we said 4 times 4 was 4 squared, and then times 4 windows. So that's an example of how we write those. Now it says, let's translate a real life situation into a numerical expression with exponents. So remember, the key here is that they want you to use those exponents, right? Most of the time in life, you don't have to use exponents, but when you are dealing with large numbers, things that you keep multiplying, that is when those exponents come in handy, right? So let's look at this example here. It says each of the 12 tables in Alan's Alan's cafe can seat 4 people. So again, information. We had 12 tables. Each of those tables can seat 4 people. One evening, Alan counts the customers. The 4 corner tables are full. 2 tables by the window have 2 people each. And a table by the door has 3 people. And it does say that 2 of them leave as he starts to count. So there's a lot of stuff that's thrown at you. And a lot of times with these math problems, it helps to just draw a picture if you're having trouble realizing, right? But what they're going through over here is they're just explaining to us how many people are at each table. So that first 4 tables at the corner, remember, each of them can hold 4 people. So those 4 tables are going to have 4 tables times 4 people each. That's just 4 squared. Then we have 2 window tables with 2 people each. So that's 2 squared. Then the other table, we have 3 people that were there, but 2 left. So we're down to just 1, right? But they're just writing it all out as an expression. That's what 3 minus 2. So we had 3 people, 2 left gives us just 3 minus 2. So if you were to write that whole thing out as an expression, this here is what we would end up with. 4 squared plus 2 squared plus 3 minus 2. You do the math over here, just following the order of operations is pretty straightforward. And we get 21 customers, right? Now again, this might seem like a scenario that doesn't make sense because you might say, hey, Mr. Correa, I can count up 21 people faster than it takes to do all this, right? But again, the idea here is we're just getting you guys in the habit of being able to do this so that when we throw a really complicated question at you, you already know how this works, right? So if we said, you know, there's 50 tables in his restaurant, each table holds 25 people, and they give you a scenario like this, right? It's going to be a lot easier to then multiply those numbers out instead of going through and trying to count every single person over there, right? So the idea with math is usually to start with a simpler problem first to make sure you understand the process, and then you can extend that to something that's more complex, right? Just giving you guys some background on why we're even doing this for what might seem like a simple problem. All right, so this gives us another example over here. It says Betty goes to a library where she is allowed to borrow 5 books every week for 4 weeks, right? So if she wanted to, she could 5 books, another 5 books. So altogether, she might be able to borrow 20 books, right? Again, that's something that's really easy to figure out just by looking at the numbers in that scenario. It says Kevin goes to a library where he is allowed to borrow 2 books in the first week. For the next 3 weeks, he can borrow double the number of books he could borrow the previous week. So let's see who can borrow more books, right? So we're going to know that Betty can borrow 20 books. That's what I went over. And the way they did that is 5 books, 5, 5, 5, 5 times 4 gives you 20, right? And yes, we do see your name here, Kevin. I'm assuming that you do like to read a lot of books, right? So the next one for Kevin's, it says that he can borrow 2 books and then it's going to double in number for every successive week. So we start off with 2 books, right? The next week, we just double it. So 2 times 2, or we could write that as 2 squared, is going to give him 4 books for that second. The third week is going to be 2 times 2 times 2, or 2 to the power of 3, which gives him 8 books that he can write. The next week is 2 to the 4th, so 2 times 2 times 2 times 2, which is going to be 16 books that he can write, right? Now, I'm not sure where this 30 came from, right? Let me just reread this here because I'm going to say that looks like a typo for me. Okay, so this looks like a typo to me, right? If he's able to borrow 16 books this week, the following week, again, he can still borrow twice as many books as he borrowed the week before. So can somebody tell me how many books should he be able to borrow for this last week on week 5? Actually, wait a second. No, my bad. That's just adding up how many. I was thinking about week 5, right? So this here is the total that he could get. Sorry, I misread the question, which does happen, right? So he borrowed 16 books, plus 4 books is 20, 8 and 2 is 10, so he can borrow 30 books altogether in 4 weeks, right? Sorry if I confused you guys. I was thinking this represented week 5, right? So after 4 weeks, he can borrow 30 books. After 4 weeks, she can borrow 20 books. So you can see here that the amount of books that Kevin can borrow is 30, all right? Any questions on this part here? Sorry if I confused you. Okay, good. Yes, Alfie, I think we're all tired. All right, so there's a question over here. Okay, so how do we get 30? Good. So the reason that they got 30 is we're trying to see how many books can he take out altogether after that 4-week period. So this 30 here is really just, they got that by doing, whoops, why am I on the line? 1 second. So 2 books for week 1, plus 4 books for week 2, plus 8 books for week 3, plus 16 books for week 4, gives us 30 books altogether, right? And easy way to see that addition is I usually group things when I add. So I would say, okay, I know 2 plus 8 is 10, 4 plus 16 is 20, so altogether that gives me 30. Right? And if we were to go on, right, to say week 5, at week 5, Betty again could order another 5. Kevin at week 5 would be able to order 32 books because his keeps double, right? So something else that you're going to see to give you guys a heads up, higher level math class is like when you get to 8th grade math specifically, you start talking about exponential growth. So because this keeps doubling, it's going to grow really fast, right? After, say, 10 weeks, he would be able to order 2 to the power of 10 books. Does anybody think they have an idea of how big this number would be? If I just took the number 2 and I multiplied it by itself 10 times, you think that's going to be a big number? Just any guesses in the chat. How big do we think that is? You think it's going to be like above 100, above 50? How big do you think that number could possibly get? If I'm just taking the number 2 and multiplying it by itself 10 times, all right? And just something that we want to remember, right? 2 raised to the power of 10, that's not the same thing as 2 multiplied by 10, right? They're 2 different things. What this here means is this means 2 times 2 times 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, 2 to the power of 10 means 2 times 2 times 2 times 2, 10 times, right? And if I was actually to do that in a calculator, you're gonna see that that might be a lot bigger than you were expecting. So let's check that here really quick. That would be 2 times 1, 3, 4, 5, 6, 7, 8, 9, 10, right? So 2 to the power of 10 is actually over 1,000, right? It gets really big really fast. And that's just something that you start to look at once you get to like 8th grade math, right? You start looking at this, what we call exponential growth, and it makes things a lot bigger, all right? But that's just kind of like a preview of what you're gonna see in future grades. Whoops, I just closed that by mistake. All right, I believe we are almost done with this material though. Sorry about that. All right, so again, you've got an example over here. I'll just read through it and you guys should be doing this one on your own. It says, Raul is building a house. On day 1, he uses 3 bags of cement. On each of the following 3 days, he uses 3 times the number of bags used the previous days. And then this one here is asking us how many bags of cement does he use in the last 3 days, all right? So work this out here if you want. It might help to write, you know, day 1, day 2, day 3, and then figure it out from there, all right? So I'm not gonna go over that one. I want you guys to work it out. If you do have questions, I will try to help you out after we're done with the lesson for today, though, okay? So we're up to the summary for today. Just read this out together. Remember, the key thing is remembering this PEMDAS. Please excuse my dear Aunt Sally. It says, we use an exponential expression to show a number multiplied by itself a number of times, right? So looking at, say, 4 to the power of 5, you want to be careful. Remember, that's not equal to 4 times 5. That's what a lot of students make the mistake of. 4 to the power of 5 is actually equal to just 4 times 4 times 4, 5 times. So exponential expressions are just telling you what to do with the numbers, all right? It says the number is multiplied is called the base. So this number right here, this 4 in this case, is our base. The 5 in this case here is our exponent. Right? Try to remember that vocabulary. It's going to come up a lot moving forward, and your future teachers are just going to expect you to memorize that, all right? When you write and evaluate numerical expressions, the order in which you perform the mathematical operations is important, right? It is very important. It says you can remember the order of operations using the acronym PEMDAS, all right? So again, most people already know it. Just remember multiplication or division, addition or subtraction. And over here is just telling us what PEMDAS stands for. And remember the key thing over here, I'm glad it does a good job of reminding you, is when multiplication and division are part of the same expression, you need to perform each operation in the order in which it appears from left to right. So it's always from left to right. Yes, 4 times 4 times 4 times 4. Yes, this expression here would be equal to 1024. And just to show you also another reason why, right? 4 times 4 is equal to 2 squared. Again, this here is equal to 2 squared times 2 squared times 2 squared times 2 squared. Over here, this is like saying I have 2 2s, 4 2s, 5 2s, 2, 4, 6, 8. I have 10 2s. So this expression is actually equal to the same one we saw on the last page, right? It's also equal to 2 to the power of 10. And working like this over here, converting expressions that have different exponents is something else that you're going to be doing a lot more of in 8th grade math. All right, but hopefully you see the connection there. I'm glad that people are working the math out there. Good job, Sissy. All right. So we're pretty much done with the lesson for today, right? If you already finished through everything over here, what you're going to do next, not yet, Alfie, what you're going to do next is go ahead and start working on that mastery test, right? I should have unlocked the mastery test this morning. So if it was locked yesterday, you should see it unlocked today. If you try it, you fail it, and you can't try it again, for some reason, sometimes it's not always unlocking, just shoot me an email and I'll unlock it for you, all right? Is a game that involves the order of operations, right? So if you go back to the iLearn class page and you look through here, you're gonna see an order of operations game, all right? So just click on that link there. It's a fun little game that involves the order of operations. I'm just gonna explain to you how it works, and then you guys can try it on your own pace, all right? So give it a second to load. I don't think it needs flash or anything. So you can redo the scenario if you want. Basically, you're gonna have a safe here. You're trying to figure out what's the combination for the safe. So the way it works is first you have to click on what you would do first. So in this case here, this is way too loud, sorry. What you're gonna do first is you're gonna click on what comes first. So if I was trying to work out this expression, which piece would I do first? Can somebody tell me? Just type it in the chat. And we are timed here, right? So this red bar here is going down and you want to try to answer it fast, right? Good, so 9 minus 7. So I'm gonna click on 9 minus 7. And now I have to scroll this to whatever the answer would be. So 9 minus 7 is gonna give me 2. There we go, right? Now I do the next part. I say, what am I gonna do next? I just did the parentheses. Which piece should I do first here? I'll wait for somebody to give it to me in the chat. Okay, so I see 2 options. I see somebody said 2 times 5, somebody else said 12 over 2. So we have to be careful, right? Remember, when we talk about PEMDAS, we do multiplication or division, whichever one comes first from the left to the right. So you actually need to do this piece first, right? Remember, it's multiplication or division from left to right. So this piece comes first, right? 12 divided by 2 needs to come before 2 times 5. If you did this piece first, you're going to end up getting it incorrect, right? And that's fine if you got it wrong now, but just take your time with it, right? This is a good opportunity to practice that, okay? Remember, it's always going to be, let me just again write that on the left-hand side to reinforce it, parentheses first, then your exponents, then your multiplication or division. Again, whichever one comes first, left to right, and then the same thing, addition or subtraction, right? That's the key order when you're doing this. So I'll finish working through this first example here. So 12 divided by 2 gives us 6. So let's scroll this wheel to 6. What am I going to do next? Somebody help me out. I see 6 plus 2 times 5. Good. Now I'm going to do that multiplication next. 2 times 5 is going to give me 10. And then lastly, I'm left with just 6 plus 10, right? 16. Right? So that gives us the first number. You can see that we have 4 pieces and also the timer is still going. So try this out after you finish the lesson for today, after you finish the mastery test, and see if you can finish this out, find the combination before you run out of time. All right? So I'm going to end the recording for now.